Hello everyone. Today we will discuss about error detection and correction. Now we are in the chapter 10 of data communication. So moving on. Errors. Everyone know what is the error. A condition where the receiver's information does not match with the sender information is known as error. There are types of errors. One is the single bit error. If you have one bit error is known as the single bit error, and the burst error, if there are the several bit errors, is known as the burst bit error. So this is the diagram of single bit error, and this is the diagram of burst bit error. Now the redundancy. Redundancy means the same data is sending and receiving again and again. It is known as the redundancy. Now coding. In coding section we already discussed about block coding and convolution coding. In block coding section, the block coding we divided down messages into blocks is known as data words is in the block coding. Error detection. We already know what is error, and error detection is means to find out the error is known as error detection. How can error be detected? By using block codings. In this section we have encoder and decoder. Encoder are in the standard section, and receiver section we have decoder. First of in the k bits we send the data word, then the generator used some bits to add it with the data word and then send this code word to the next level, and then receivers receive the code word and the checker checks the generator section with the data section, and if it is okay then it will send to the data word. That's how the error is detected by block coding with blocks. Here are some descriptions, you may go through them. Now Hamming distance. Here are some examples of Hamming distance. By this Hamming section you can easily find out how to describe and detect the Hamming distance. By this Hamming distance, this is used for error detection and correction. Now the parity checking. Parity is nothing but a simple bit which is added after the data, which looks like this. Here we have data word and generator creates a parity bit. When we added the parity bit with the code word and sent to the next level, and in the checker section we check the data with the parity bit. If is it okay, then the receiver can acknowledge that this data is okay, and if it is not, then it will send a negative acknowledgement. That is how the parity checking works. Now the cyclic code. In the cyclic section, here is a cycle generated where the same ports are connected with each other, generates a separated value, and another produce the difference values. That means if you multiplies a with a, you can have the value of suppose 4, and a port to b port, it will generate a value of 0. So when the 0 is multiplied by another one, the result outcomes with the 0, so that means there was an error, and if there is a value, so there is no error. Now the CRC, which is known as cyclic redundancy check, is used for encoding and decoding. The CRC or cyclic redundancy check is very important for your exam point of view. In this section we need to have a data word, and after this data word we need to add some zeros. If you have n plus 1 number of datas, you need to add n number of zeros with the generator. After adding this reminder section, the send this code word to the next level. After receiving that, the checker will check this condition and matched with the function. If these are matched, then it will send the data is okay and receive to the receiver. That's how the CRC encoding and decoding are used. Encoding is to add the codes with the code word, and decoding is for decode and separated the data and reminders. Sometimes the polynomial functions are used in CRC. The polynomial functions are used to generate the generator. By this generator, we can add the number of zeros and ones by this polynomial function. So the polynomial is connected with the CRC section. The degree of polynomial. The degree of polynomial is the highest power of polynomial. For example, the degree of polynomial here is the 6. So here the degree is 6 because the highest degree of polynomial is here x to the power 6. That is for today. Thank you.